Today's video lesson is over topic 2, which is called Introduction of Functions. And our driving question is, what are the properties and characteristics of a function? As always, you should definitely be using Cornell Notes. So first of all, I want to make the statement that an equation or a graph can represent a relationship between two variables, and we call that a relation. So again, it could be either an equation or a graph, but whatever connects the two of them together is called a relation. Now these relations, when shown on the graph, can either be a continuous graph or it could be a discrete graph. So we talked about this in class, but a continuous graph is one that is unbroken, and you'll see a solid line or curve, versus a discrete graph, which is composed of distinct isolated points. So it has specific points on the graph. They are not all connected through a line. Now you definitely hear us use the word function a lot, and just know that a function is a special type of relation that pairs each input value with exactly one output value. So think of a function as a machine where something goes in and then it gives you something else out. So the things that go in, we either call the input value or the independent variable, which is typically what we use X for. It doesn't have to be the letter X, but that's normally what we use. And then what comes out is called the output. That's called the dependent variable because it depends on the machine to figure out what it is. The independent variable knew what it was going into the machine, but the dependent variable needs the function to figure itself out. And this is typically Y, but now instead of Y, you may also see it written as F and then in the parentheses X. We say that F of X, meaning it's a function of X. I want to quickly go back to the things that were written up here on top. We are going to end up talking about the domain and the range, but I'll just at least give you a brief introduction. The domain is the collection of all the input values, and the range is the collection of all the output values. So now that we know what a function is, we want to be able to figure out what is and is not a function. So here are the ways that different relations might be shown to you. They might be shown to you in a graph. Maybe there's a table, or sometimes we have what's on the bottom right, which is called a map. And a map connects the values from the domain to the values in the range, which we know are our inputs and our outputs. But anyway, the easiest one is to use the vertical line test on a graph. So the vertical line test is, you could imagine this invisible line that starts somewhere to the left of the graph, and then slowly that line is gonna sweep through the entire graph until it ends up over here. You could imagine holding up your pencil and just spreading it across the graph. So keep that invisible line in mind. But anyway, as that invisible line sweeps through the graph, it should only hit the graph at one point. So let's say the next one is here. That one only hits at one point, which is right there. And then it keeps sweeping through the graph, and each time it goes through this graph, it does indeed only hit at one point. So that means, yes, this is a function. So I'll write function down here. Now on the second graph on the right, when we still have that same line, at first, as it's sweeping through, it continues to hit in only one spot, which is good. But then once it gets to other positions, notice that it starts hitting in more than one location. The second that it hits in more than one location on your vertical line test, right away we know that is not a function. So like I said, that's the easiest way to tell with graphs. Now let's go to the bottom left though. We have a table. Now, on this table, you have to look very specifically. We mentioned that each x value can only go to exactly one y value. So it's okay for y's to repeat. For example, I see a 7 here and a 7 down here. That's okay. What's not okay is that I have a negative 1, I'm sorry, going to 3, and another negative 1 going to 9. The reason that's not okay is because think back to the machine. If I give the machine a negative 1, it needs to give me back a number. And based on this, the machine wouldn't know whether it should give me a 3 or a 9. It'll be confused. So this is not a function. You cannot have multiple x's that are the same going to different y's. Now over here on the right, I have some numbers that repeat. Like again, I have 12 and 12 and y's. That's okay. But I have no x's that are repeated. So this is a function. The machine will never be confused because it'll know exactly what number to give me every time I give it an x value. And on the last one, on the bottom right, when we talk about the map connecting the domain and the range, here it shows arrows. For example, if I were to give the machine a 3, it'll follow the arrow and it knows to give me a 1. It's okay for two numbers to be mapped to the same one. Whether I give it a 7 or a 9, the machine's going to know to give me back a 4. So there are no problems here. This one is a function. The second one though, it'll know what to do for 5, 7, and 9, but when I give the machine a 3, it won't know whether to give me back a 1 or to give me back a 6. That's going to confuse it. Again, every x value can only go to exactly one y value. So this one is not a function. So while we're on the topic of domain and range, let's talk about how to show those. So you might have a discrete graph with isolated points, and the way that we talk about domain and range is to actually write a set or a list of numbers. So you might see the actual word domain written out, but don't be surprised if you just see a D and an R to represent domain and range. So we mentioned that the domain are the x values or the input values, which is across the horizontal axis. So before I even start putting all my numbers in, let's look at these ordered pairs. So my first dot happens at 0, 0. The second one happens at 2, 1. You do have to list the x value before you can list the y value. The third one happens at, it looks like 4, 3. And then the fourth one happens at 6, 2. So now that we can see all the different points that are on the graph, it's all the x values or the input values that go into this list. Now you do use a curvy bracket to start the list, and then we just number them. So I see a 0, that's the first one, and then a 2. Again, I'm only listing the x values, a 4, and a 6. So that's my domain. And then under the range, we list the output values or the y values. I had a 0, a 1, a 3, and a 2. It's okay if they're out of order, but if you're taking a test, you probably would see them in order. So you might see the 2 first, and then the 3. So that's how we show domain and range for discrete graphs. Now, if we have a solid line though, like with a continuous graph, we have an infinite number of dots along that line. So instead, we write it as an inequality. So we're going to have an inequality with x and one with y to represent our domain and range. So our x values, well, they start at 6 because this line is going in units of 2, and they go all the way until the number 20. So I know I'll have that my x values go from 6 to 20. And just like in our last topic when we were studying inequalities, the first one has an open dot. So I'll have this symbol. And then the next one is a solid dot. So it'll have that dash underneath. So this is saying that I'm using the x values between 6 and 20. But it actually includes the 20, it doesn't include the 6. Now the other way around are y values. The lowest y value that is used is 15. So that goes over here on the left. And again, it's an open dot. And then the highest y value that it uses, it looks to be 35. But that's a solid dot. So this is how we write our domain and our range for continuous graphs. In just a second, on the next screen, we are going to practice domains and ranges. But before that, I do want to talk about parent functions. So now that we know what functions are, there are a few main functions, I guess you can say. There are more than this, but these are kind of the most basic ones that we're going to be working with in Algebra 1. So notice that I started using what's called function notation. So I'm using f of x instead of writing y, but know that they are the same thing. So again, f of x is the same thing as y. They are interchangeable. So the first parent function is where f of x or y is equal to x. That means all along this line, for example, when x is 5, then that means y is 5. Or when x is 10, that means y is also 10. They're going to match each other. And because this is a straight line, this is called a linear parent function. Linear. Now, the next one has f of x equals x squared. It looks like a parabola. That's what it's called. It's a curve. Just so you know, the name of this one is a quadratic function. And it's non-linear, just meaning to say it's not a straight line. The one on the bottom left, this one is called the absolute value parent function. Again, it's non-linear. Now, parts of it are straight lines, but the whole thing together doesn't make one straight line. So it's non-linear. And this last one is called the square root function. And again, because it's not a straight line, it is non-linear. So you will be learning more about all of these functions throughout the year. But for now, I just wanted to expose you to them. And I also wanted to talk about the domains and ranges for each one. Might as well to get practice. So let's look at the linear function first. So if you notice those arrows at the end means that they're going to go on forever in each direction. So it's going to use all of the x values, both in the negative direction and in the positive direction. So for the domain, you can write this R symbol that has two lines on the left hand side. And what that means is all real numbers. So it's going to use all the possible numbers from negative infinity to infinity. And now for our range, well, it's going to go downward forever. So it's going to use all of the negative y values. But it's also going to go upwards forever. It's going to use all of the positive y values. So once again, our range is the set of all real numbers. Let's move on to the second one, the quadratic function, f of x equals x squared. Well, to the left and to the right, for x values, it's going to use all of them. I know it looks like the arrows are going straight up, but they're actually very slowly and steadily going to the sides. So our domain, once again, is a set of all real numbers. But let's look at our range. Our range, it doesn't use all the y values. It only uses the top half of the chart, starting at the number 0. It never uses anything less than 0. So for this one, we would write y greater than or equal to 0, because it's going to use all the y values greater than or equal to 0. The next one is very similar, the absolute value function. Absolute value says that whether or not my x is negative or positive, it's going to give me nothing but positive numbers in return. It does use all of the x values, so our domain is all real numbers. But again, in return, our range, it's only going to give me positive numbers, the lowest one being 0. So once again, our range is all the y values greater than or equal to 0. And now the last one, the square root function. So this one only uses x values starting from 0 and then going forward, because we cannot take the square root of a negative number. So in this one, our domain is only the x values that are greater than or equal to 0. And in return, it'll only give us other positive values for y, so our range is y is greater than or equal to 0. So to recap, we talked about graphs being able to be continuous or discrete and what makes a relation. We talked about functions, all the different names for the things that go into the function, and all the different names for the things that come out of the function. We learned how to test for what is and is not a function, because remember, not all relations are functions. And then lastly, we talked about the characteristics of domain and range, and how they look different for discrete graphs and continuous graphs. We also showed what domain and range look like for the parent functions, which are definitely functions, it's in the name, but they're kind of the most basic functions of each characteristic. Notice that they all look different, and so they're like the parents of their category. Some functions are linear. Well, I should say one type of function is linear. It even has the name of a linear parent function. The other ones are non-linear, but there are multiple ones and they have different shapes. So that's pretty much all you need to know about functions for now.